My voice is audible to all now? Mohit, Prasad, Harshad?
हो सर, आवाज येत आहे.
Okay. Now see, we will move forward with the syllabus of fluid mechanics. This syllabus is implemented from this semester. New scheme will be there. There will be nothing change in the syllabus of fluid power 1 and the fluid mechanics. Only name is changed, fluid power into fluid mechanics. So from today we will move forward the unit number 1. Unit number 1 consists of various properties of fluid, what is meant by mechanics, what will be the branches of mechanics, how we can define the fluid mechanics. There are different properties of fluid mechanics. Some basic simple formula, laws are included in this fluid mechanics. And our experimental studies also start with the unit number 1, that is nothing but the manometer. So first will be the course learning objective of the course fluid mechanics. So what will be the objective defined by the university? First one, to introduce and explain the fundamentals of fluid mechanics used in the application of hydraulics, aerodynamics and gas dynamics, etc. Second objective will be to give the fundamental knowledge of fluid, its properties and behavior under the various conditions of external and internal flows. Third one, to develop the understanding about hydrostatic law, principle of buoyancy and stability of the floating body, and the application of mass, momentum and energy equation in the fluid flow. Fourth one, to imbibe the basic laws and equation used for the analysis of static and dynamic fluid. Fifth one, to incalculate the importance of buoyancy, layer flow and its application. And sixth one, to determine the losses in the system flow through pipes, impact of the jet. These are the 6 options. What will be the outcome of this course? After studying this total course 6 units, students should be able to identify the importance of various fluid properties at rest and in motion. Second one, derive and apply the general governing equation for the various fluid flow. Understand the concept of boundary layer theory and flow separation. Calculate the energy losses in the pipe. Evaluate the performance of characteristics of hydraulic jet. These are the 5 outcomes of the 6th unit. So, which contents are included in our syllabus unit number 1? So, there are 2 parts. Unit 1 will be divided into 2 parts. First part consists of basic properties of the fluid that will be covered in today's lecture. And second consists of pressure and its measurement. That is nothing but the study of manometer. Is it correct? First unit will be divided into 2 parts. From today's lecture, we will move for the first part, which include basic properties of fluids such as density, specific weight, specific volume, specific gravity, viscosity, surface tension, capillarity, vapor pressure and cavitation. These are the various properties of fluid. And in the second part of the unit consists of pressure and its measurement. So how we can measure the pressure? It consists of Pascal law, hydrostatic law of the pressure, pressure variation in the fluid, measurement of pressure by the manometer. So start with the what is meant by mechanics. Fluid mechanics consists of 2 words, fluid and second one is mechanics. So before going for the fluid mechanics, we will see the word what is meant by mechanics. So already those students are coming from first year. I already taught the subject engineering mechanics. So what is meant by engineering mechanics? Engineering mechanics is a simple branch of engineering science that deals with the study of forces acting on the body when body is in motion or is at rest condition. That is called as mechanics. So while we are going for the fluid having 2 types. One is liquid and second is gas. Okay, gas is also one type of fluid. There are 3 states: solid, liquid and gas. So solid is the other part that will be included in our engineering mechanics, and fluid and gases should be included in fluid mechanics. So केव्हाही तुम्हाला विचारलं जाईल what is meant by fluid or types of fluid. The types of fluid 2 प्रकारचे, gas and liquid. Okay. So here what is the definition? It is the oldest physical science. Physical science is nothing but the engineering science. Okay. mechanics is the oldest physical science that deals with the study of stationary and moving bodies under the influence of a forces. Okay, that is nothing but the definition of the mechanics. So which type of branches are available in the mechanics? Mechanics having two branches, static and dynamics. So what is meant by static? Static means the study of forces acting on the body when body is at rest condition. That will be called as static condition. And when body is in motion, then this is called as dynamic. So dynamic again is divided into two parts. First one kinematics and second one kinetic. So what is meant by kinematics? Kinematics is nothing but the study of forces acting on the body when body is in motion, but external force of agency is not considered. That concept is called as kinematics. And when the external forces are considered, then this will be called as kinetic. Okay. So subcategory of fluid mechanics is defined as the science that deals with the behavior of fluid at rest, that is called as fluid statics, or in motion called as fluid dynamics, and the intersection of fluid with solid or other fluid at the boundaries. See, now here we have to study the three aspects of the fluid mechanics. First one is the static aspect, second one is the dynamic aspect, and third one is the boundary condition. When there will be the intersection of two fluids, or it will be the intersection of solid body with other fluid. It creates the boundary layer. फॉर एक्झाम्पल आता आपल्याला माहित आहे फ्लड्स आलेले आहे, नदीला पूर, नाल्याला पूर आलेला आहे. बघा आता जर तुम्ही एखाद्या धरणावर व्हिजिट दिली असेल, पाणी तर पूर्ण गढूळ आहे, पण धरणाच्या पाण्यावर एखादा लेअर बनलेला असेल, इथे काय एक लेअर बनलेला असेल, तो शेवाळचा असू शकतो, काही घाण कचरा असू शकतो, but it creates a layer. That layer is called as boundary layer. The intersection between solid body and the liquid surface, that is called as boundary layer. Is it right? आतापर्यंत कोणाला काही अडचण आहे?
Is
there any? Okay. So shall we move forward?
Okay, sir.
Yes, sir.
Okay. So next will be the what is meant by fluid kinematics and what is meant by fluid kinetics. So fluid kinematics and kinetics, we already studied that it is the branches of dynamics. So study of fluid in motion where the pressure force are not considered is called as fluid kinematics, and if the pressure force is considered, then the fluid is called as fluid kinetics. Okay.
Okay, sir.
So, okay, now see what is meant by fluid. I already told you fluid will be the substance. Fluid is a substance exists in the three primary phases. So first phase is solid, second phase is liquid, and third phase is gas. Okay, the substance in the liquid or gas phase is referred as fluid. Fluid having two types, it's liquid and gas. The difference between solid and fluid is made on the basis of substance ability to resist the applied shear stress that tends to change its shape. Solid and liquid ला आपण कसं differentiate करू शकतो? We are going to differentiate with the ability of the body or ability of the fluid that resists the applied shear stress that tends to change its shape. Okay, the solid can resist the applied shear stress by deforming, whereas the fluid deforms continuously under the influence of shear stress. So no matter how it is small. आपल्याला माहित आहे एखादी सॉलिड बॉडी जर आपण एखाद्या शियर स्ट्रेस अप्लाय केला, एखादा फोर्स त्यावर अप्लाय केला, काय होईल? एक तर त्याचा शेप चेंज होईल, अदरवाइज इट विल बी ब्रेक. पण पाण्याचं तसं होईल का? पाण्याला तुम्ही जर एका ठिकाणी आपण शियर स्ट्रेस किंवा फोर्स अप्लाय केला, पाणी काय करेल? जिथं जिथं फ्री सरफेस भेटेल जो एरिया काय करेल तो ऑक्युपाय करत राहील. तो आपण कितीही डिफॉर्म केलं, कितीही छोटं लिक्विड असलं, पण काय होईल? shear stress will continuously deform होत राहील. Fluid काय होईल? Continuously deform under the influence of shear stress. Okay? In solid, stress is proportional to strain. हा पॉइंट महत्वाचा आहे, लक्षात द्या. In solid, stress is directly proportional to strain, but in case of fluid, stress is directly proportional to shear strain, or it may be called the strain rate. Okay? So when a constant shear force is applied, a solid eventually stops deforming at some fixed strain angle, whereas fluid never stops deforming and approaches a certain rate of strain. ओके, डायग्राम मध्ये दिलेला आहे बघा, एक रबर कन्सिडर केलेला आहे, त्यात दोन प्लेट आहे, दोन प्लेट मध्ये काय करताय, शिअर स्ट्रेन अप्लाय केलेला आहे, शिअर अँगल बनतो आहे, शिअर स्ट्रेन इथं दिलेला आहे बघा, अल्फा अँगल बनतो आहे. ओके, तो याची एक स्पेसिफिक लिमिट आहे, या लिमिट पर्यंत आपण त्याला डिफॉर्म करू शकतो. आपण जर लिमिट क्रॉस केली, त्याची शिअर व्हॅल्यू चेंज केली, वाढवली, तर काय होईल, सॉलिड बॉडी विल बी कोलॅप्स और इट विल बी ब्रेक इनटू 2 or 3 many parts. Okay, but in case of liquid, it will be continuously deforming while applying the shear stress. It will be continuously deforming and approaches to certain rate of shear strain. Okay, this diagram will be shows that the deformation of rubber eraser placed between two parallel plates under the influence of shear stress. तर तुम्हाला बघताय कॉन्टॅक्ट एरिया दिसतोय, हा जो एरिया दिसतोय आपल्याला, 1 minute, हा जो arrow दिसतोय, that will be the contact surfaces between the plate and the rubber. Here also there will be contact surface between plate and rubber. We are applying the force here, rubber will be deforming and alpha is called as shear strain angle. Okay, so what is meant by stress? How we can define the stress? It is the force upon area. So this diagram shows the total deformation of rubber under the action of influence of shear force. Now see, what is the basic difference between liquid and gas? So in liquid, see, there are two containers. First container consists of liquid and second container consists of gas. Okay, so in liquid, molecules can move relative to each other, but the volume remains relatively constant because of strong cohesive force between the molecules. Liquid मध्ये काय, liquid is nothing but there are some small molecules are there, but the cohesive force between the two molecules are strong. Then it occupies a specific space and create a free surface above the layer of the liquid. As a result, liquid takes the shape of the container and it is in and it forms a free surface in the larger container in the form of gravitational field. Now see, इथं काय बनवलं त्यांनी, पिंक कलर मध्ये लाईन दिसते, that will be the free surface will be created above the layer of the liquid. But what will be the case in case of gas? So in gas, on the other hand, expand until it encounters the wall of the container and fill the entire available space. गॅस काय करेल, स्पेसिफिक व्हॉल्यूम नाही करणार, जेवढी स्पेस आहे तेवढी ऑक्युपाय करण्याचा प्रयत्न करेल, पॉसिबली तो कंटेनरलाही क्रॉस करेल, कंटेनरच्या बाहेर जाईल, फ्री सरफेस बनणार नाही. तो काय करेल, इट फिल्स द एंटायर प्लेस अवेलेबल इन द कंटेनर. This is because the gas molecules are widely spaced and the cohesive forces between them are very small. Okay, first difference काय, the cohesive forces between the liquid molecules are strong, cohesive forces between the gas molecules are small. That will be the first difference between liquid and gas. Unlike the liquid, gases cannot form a free surface. Gas is not able to form the free surface above the layer of the gas. So here some differences are there between liquid and gases. So in case of liquid, difficult to compress and often regarded as incompressible. Liquid ला compress करून किती compress करणार? It will occupy the free space continuously and it will be deformed. Okay. In case of gas, it is easily compressed. Changes of the volume is large, cannot normally be neglected, and it are related to the temperature. Then second point will be the occupies a fixed volume and it will take the shape of the container. आता कंटेनर कोणत्या शेपचा आहे आपल्याला माहिती नाही, पण जे शेप असेल त्याचा लिक्विड काय करेल, त्या शेप फॉर्म करेल. फॉर एक्झाम्पल आपण जर आईस बनवतो फ्रीज मध्ये, बरोबर आहे, आईस क्यूबचे जे ट्रे असतात हे वेगवेगळ्या शेपचे असतात. जसं आपण ज्या शेप मध्ये टाकू तसं आपल्याला काय मिळेल, आईस मिळेल. पण इन केस ऑफ गॅस इट इज नॉट पॉसिबल. नो फिक्स वॉल्यूम, इट चेंजेस द वॉल्यूम टू एक्सपांड टू फिल द containing vessel. The free surface is formed if the volume of the container is greater than the liquid. Okay, but completely fills the vessel so that no free surface is formed in terms of gas. That will be three differences, and fourth one is already told you, the cohesive forces between liquid molecules are strong as compared to the gases. That will be the difference between liquid and gas. So start with these are the basic. Up till now we see what is meant by mechanics, what are the branches of mechanics, what is meant by fluid mechanics, which type of fluids are available in the market. Okay, so what is meant by fluid kinematics, what is meant by fluid kinetics, what is meant by fluid statics. These are some basic principles are available in the fluid mechanics. Now from this our unit number 1 start. So start with the basic properties of the fluid. So in front of you there are 9 properties are there in the part 1 syllabus of the fluid mechanics unit number 1. So first one is density, second one is specific weight, third one is specific volume, fourth one is specific gravity, fifth one viscosity of the fluid, sixth one surface tension, capillarity, vapor pressure and cavitation. These are some basic principles or basic properties of the fluid available. Basic properties of the fluid available in the syllabus. So start with our first property, that is nothing but the density. One minute. So see, properties of the fluid. Any characteristic of the system is called as property. So some familiar properties are pressure P in case of fluid only. These properties are in case of fluid only. So similar properties, what will be there? Pressure, temperature, volume and mass. There are the 4 basic properties of the fluid that will be considered while defining the density, specific weight, specific volume, vapor pressure. Okay. So capital P denotes the pressure, capital T denotes the temperature, capital V denotes the volume and small m denotes the mass. The other less familiar properties included viscosity, thermal conductivity, modulus of elasticity, thermal expansion coefficient, electric resistivity and even velocity and elevation. Okay. So properties are considered to be either intensive or either extensive. So what is meant by intensive? What is meant by extensive? So intensive properties are those independent of mass of the system. See carefully. What is meant by intensive property? Intensive property are those that are independent of mass of the system, such as temperature, pressure and density. These pressure, temperature and density are not depend on the mass of the system. So this property is called as intensive property. So what is by extensive? The properties are those whose value depend on the size or extent of the system, means it will be depend on the mass of the system. Okay. Total mass, total volume and total momentum are some examples of the extensive property. Is it clear what is meant by intensive and what is meant by extensive?
Yes, sir.
Sir, पुन्हा सांगा.
Intensive property and extensive properties are considered either it will be intensive or it will be extensive. So what is meant by intensive? Intensive property are those which are independent of the mass of the system. म्हणजे मासवर जी व्हॅल्यू डिपेंड नाही अशा प्रॉपर्टीजला आपण काय म्हणू शकतो? इंटेन्सिव्ह. फॉर एक्झाम्पल टेम्परेचर, pressure and the density. These are the some examples of intensive property. याच्यात उलट काय आहे? Extensive properties are those whose value depend on the size or extent of the system. Means it will depend on the mass of the system. This property is called as extensive property. What will be here example? It will be the mass, it will be the total volume, it will be the total momentum, are the some examples of extensive property. So properties of fluid, any easy way to determine whether a property is intensive or extensive is to divide the system into two equal parts with the imaginary partition. Now see, इथं तुमच्या समोर दोन ब्लॉक दिसत आहे. One block will be there. This block having property mass, volume, temperature, pressure, and rho. Rho means density. Okay. So this block will be divided into two parts here. This block will be divided into two parts. So mass total m आहे, तर आपण त्याला दोन पार्ट मध्ये डिवाइड केलं. So it will be 1/2m, 1/2m. Volume will be okay, 50%, 50% here. So m and v, mass and volume, is the extensive property which will be depend on mass. But the temperature is changes after dividation? No. Pressure is changes after dividation? No. Density is changes after dividation? No. So these are the intensive property which are not depend on the mass of the system. Okay, each part will have the same value of the intensive property as the original system, but half value of the extensive properties. Okay, so start with our first property, density, or it may be called as mass density. So what is meant by density or mass density of the fluid is defined as the ratio of mass of the fluid to its volume. Style definition. It is the ratio of mass of the fluid to its volume that is called as density, or it may be called as mass density. Thus, the mass per unit volume of the fluid is called as density. It is denoted by the symbol rho. The unit of mass density in SI unit is kg per cubic meter, means kg per meter cube. आपल्याला माहित आहे मासचं युनिट काय आहे kg आणि मीटर व्हॉल्यूम काय आहे मीटर मध्ये मोजतो. व्हॉल्यूम मीन्स मीटर क्यूब. So kg per meter cube. So density of the liquid may be considered as the constant while that of gas changes with the variation of pressure and the temperature. Density of the liquid is constant. Kindly note that while solving the numerical, it is very important. Density of the liquid may be constant as while that of gases changes with the variation of pressure and temperature. Mathematically, density will be written as rho is equal to mass of the fluid upon volume of the fluid. Okay, the value of the density of water is constant, that is nothing but the 1 gram per centimeter cube, or it may be 1000 kg per meter cube. That will be our assumption. It is always taken as the liquid. If density of water is given, then we have to consider that 1000 kg per meter cube. It is not necessary to give put up this value in the examination numerical. We have to assume that the density of water is 1000 kg per meter cube. Okay, आतापर्यंत कोणाला काही अडचण आली?
No, sir.
ओके, पुढचं लेक्चर